Good morning, and thank you for joining us for another HRAI webinar. This time, we're joined once again by the HVAC Designers of Canada, who are helping us present F280 software verification results, starring John Harris with DSG Building Diagnostics. Before I welcome them to the webinar, I just want to do a couple of housekeeping items. First of all, my name is Matt Bradford. I'm the host of the HRAI webinars, and if you'd like to do your own webinar, I would be happy to set that up with you. If you want to get in contact, mbradford@hrai.ca, or through the website as well. Now, for this webinar, we got a lot of great information, so I'm not going to take too long. If you have questions, John will be taking those throughout the presentation. You can put those, if you look at the bottom of your Zoom screen, you'll find a Q&A button. You can put them in there, or the chat will be checking each one. Last thing, we are recording this, so if you'd like to watch later or share it with your colleagues, you can find it at HRAI's YouTube page. So with all that out of the way, now I'd like to introduce Mary and John. Mary was with HVAC Designers of Canada. Mary Manti, there she is. You might recognize her from a few weeks ago. Thank you so much for coming back, Mary.
Thank you.
Awesome. I'm going to give it over to you.
Thanks, Matt. So I'm just going to take a couple minutes to quickly introduce HVAC Designers of Canada for those of you who are not familiar with who we are, and then I will pass it over to John for the presentation. Can I get the first slide, John?
Oops. There we go.
Thank you. So HVAC Designers of Canada is a national association, and we represent heating, ventilation, and air conditioning designers across Canada. And we try to work with other stakeholders to deliver comfort and value to HVAC systems in Canada. So that is HVAC legislators, building sector organizations such as HRAI. We work with manufacturers, contractors, installers, builders, other government agencies, and authorities having jurisdiction. Again, with the goal of delivering the best quality HVAC systems that we can. So we have four main pillars. First one is advocacy, and all of these pillars, the main goal is to create comfortable and efficient indoor environments in specifically residential and small commercial, so Part 9 buildings. So for advocacy, we are working on supporting and promoting the growth of the HVAC design industry. So outside of Ontario, there's a lot of work to do on that front. Second is quality. So we want to maintain and enhance the quality of HVAC design in Canada. And we're doing that in a few different ways right now, but we're trying to bring some quality control to the industry. Capacity building. So we want to make HVAC services available to all Canadians. Again, outside of Ontario, it's a little bit harder to find. So our goal as a national association is to, across Canada, make that service available to people. And finally, to clarify and improve HVAC design standards goes with quality, but again, trying to bring some regulation to the industry that hasn't had a lot in the past. So that's a quick overview of who we are. If you want to learn more or to become a member, you can scan the code here or visit us at our website, hvacdc.ca. You can also contact me for more information. Over to you, John.
Thanks, Mary. And this project I'm going to talk about today actually speaks to more than one of those pillars, so it's kind of neat for me to have that review with Mary. We've been working with NRCan's LEAP team, help me out here, Leadership in Energy Efficiency Programs or something like that. They're part of Natural Resources Canada. There's a bunch of projects that have been ongoing through both HVAC DC and others, including developing some videos. They've got an app for decision making, and they're about to release an app for heat pump sizing and selection. It's saw a preview of that just a while ago. A variety of workshops being delivered on behalf of that, and specifically at this point, the sizing of equipment and doing load calculations. And specifically, we've taken a project of verifying software for compliance against F280, and we'll talk about that as we go on. And then a variety of other things coming down the pipes as well. So NRCan, as they've been sort of trying to gear up to inspire the HVAC market to do better from an energy efficiency point of view and a greenhouse gas reduction point of view, they've realized that today's heating equipment is still commonly oversized, in some cases by a factor or two of 2 or 3. This is both in new housing as well as in retrofits. Mary's already pointed out some of the differentiation. In Ontario, we've done a bit better. We've had some regulatory oversight that has made us do the job here. But my understanding outside of Ontario, it's not quite as rigorous, to say the least. Better sizing specifically for heat pumps makes things more affordable, makes it more likely to happen, makes it more likely to save the energy and the greenhouse gas emissions that we're hoping for and projecting. And one other interesting thing, and this has been grabbed onto by the utilities, it can reduce the burden on the grid. So, you know, if you were to put in a 3-ton heat pump when a 2-ton heat pump will do, you're putting more load sporadically, not over the long term, perhaps. You're still heating the same house. And if even worse, if that inspires a service upgrade to the house, then the utilities have to acknowledge that and take action based on that. So this is sort of a spin-off thing that we've become aware of more recently. Clearly, this presentation and a lot of what I'm talking about is biased towards heat pump because it is the direction we're going. It's not that these things aren't applicable to a typical gas or even an oil-fired installation. It's just that sort of the magnitude of the benefits is maybe not as great. So HVAC DC's role is to move the market through advances in code compliance. Software verification is what I'm going to talk about today, but then it gets linked with municipal engagement, and we've got another project on the go on that front. And finally, designer accreditation. So there's sort of 3 phases to this, of which I'm going to cover primarily this first phase of software verification. A lot of people have been working on this for a long time. CSA F280, the standard we use in Canada for load calculations, was revised in March of 2023 to include testing protocols. There was like 1 or 2 other editorial changes made at that time. There was a correction to one of the tables, if memory serves, but really it was adding section 8 to the protocol and then a whole bunch of tables and just piles and piles of tables to help us test software. What that is in sort of a very short overview is 4 archetype houses. One's just a fairly typical subdivision 2-story detached house. There's a walkout basement house with a lot of glazing in it, and then 2 flavors of townhouse to try to get a broad covering of the types of buildings that we have to work with. Within those 44 archetype houses, we developed 48 separate tests. I shouldn't say we, I wasn't involved with that phase, but the CSA committee. So 48 separate tests ranging from ventilation type to window orientation. Parallel activities have been ongoing to help building departments sort of bring the HVAC design review process into their normal procedures, as well as to accredit designers. The most important work, well, maybe arguably some people differ with me on this one, but the first sort of thing that had to be done was understand what actually constitutes an accurate load calculation. And a nod to Dara Bowser and other who did a lot of disciplinary work, a lot of modeling, a lot of sort of data analysis. And, you know, I wasn't involved with that scope, but what they were doing in the background was sort of saying, okay, when a certain error comes into the calculations, when does that trigger either an equipment change in size, or at the room by room level, a distribution change in size? So, you know, sticking with just forced air heating, when the size of the pipe to a room or the number of runs to a room is changed because of that error. So if I understand correctly, that's how they did their thresholds here. And they decided that for the whole house part of your load calculations, we should never be less than 2% below the correct answer and never more than 20% above. Below, because you don't want the house to get cold or hot in the summertime, and above because of those things about equipment sizing thresholds and triggering a larger piece of equipment that's not necessary. For years and years and dealing with HRAI training and other stuff, oversizing is sort of, I've been quite willing to sort of diminish it because from a cost point of view or the equipment point of view, because in standard gas furnaces, the incremental cost of the furnace is pretty small. But as soon as you bump the furnace up, you're also bumping up the duct size. In the case of heat pumps, you may be bumping up the electrical service size, et cetera, and so forth. So this 20% threshold of the tolerance of the software was where these kind of factors started coming in. I want to be really clear that this is not about equipment selection, that we've got thresholds for that either in F280 or in other standards. So equipment selection is separate from this number. This is just what deems the software to be accurate. In other words, it's reliable enough for you to go then and apply those equipment selection factors. So the one that's in F280 is, of course, the 8 for air conditioning, for heat gain, is you select equipment that's between 80% of the design load and 125%. That's a second step. That's after this. These numbers are just for us to prove that a given software is accurate. On the room side, we decided, well, there's lots of more room for tolerance there. If nothing else, I've got a bit more control of distribution with dampers and such like. So they decided, again, for the same sort of reason, -10 is probably okay. If the room gets a bit chilly, you'll pick up a bit of heat from other rooms. You can always throttle down the other rooms. And we don't mind going more 100% above the theoretical correct number because once again, I can always damper the ducts down or throttle back my hydronic or whatever it might be. Or if it's electric baseboard or something of that nature, the thermostat will just cycle. So it's not great maybe to be 100% oversized on the room. And I should qualify that again, that means the calculation is 100% inaccurate. I shouldn't say oversized in this context. But there's a lot more ability within the system design to accommodate for that and make sure we achieve the comfort. This affects equipment size and other things as well. This affects basically its comfort. Am I getting the heat to the right room? And they felt as they did their analysis, they've got more control over that to allow these wider tolerances. But at the same time, some rooms have very small loads. So they also put another cap of 500 BTU. So as long as you're within 500 BTUs per hour, you pass, whether it's in some small loads, and I've been looking at this recently with one software we're looking at, it's like 35% less than the design load, but it's only like off by 250 BTU. And once again, if you're doing forced air distribution, you're going to get a lot more heat through a single 4 or 5 inch pipe than that 500 BTU threshold, let alone the actual load in that room. So we put some common sense tolerances in with this number. Again, I want to repeat what I just said. This is the design load. This is, do you as an HVAC designer using a given software, do you actually get an accurate number? The equipment sizing is then the next step that comes out of this. One other thing to remember as I talk about this, is it the correct number? It all does depend on your inputs. You still have to put stuff in accurately. We're presuming, and this is why we develop all the tables that are in F280, we're presuming the designer has done a proper takeoff or whatever the graphical interface in your software might be, does the proper geometry numbers. We're just saying, given the right geometry, does it produce the right number? So that's the purpose of this task, of this protocol and of the numbers we did. Yeah, sorry, I got ahead of myself there. So that's the reliability of the inputs. So don't forget, the reliability of the inputs is on you as the designer, not on the software. The software can't read the drawings for you. Well, some of them do have fairly good graphical interfaces, but you're the one responsible for making sure the inputs are accurate. Why is this necessary? Why are we doing this? Well, there's been some research done and some preliminary testing based on the protocols, and what they found out is that things actually weren't lining up. So let's start here. Here's in this sort of hashed little, what is that? It's not dotted, it's whatever you want to call that, texturing there. These are the manual calculations for heating and for cooling. And they then also did some experimental results. I can tell you, I believe anyways, that this is based on the CCHT house that NRCan has, the Canadian Centre for Housing Technology. They have a pair of identical houses. It is one of the drawings we use in the testing protocols. And they have all sorts of metering and gauges and stuff like that. So they did a manual calculation and then actually monitored the house and said, yeah, at design conditions, it's using this. So, 20, I forgot my scales here, it's going to be about 30,000 BTU heat loss, and the actual experimental data or clocking of the gas meter or whatever it was they did came in at whatever that is, 33 or something. So pretty good alignment there. Cooling, they didn't bother clocking that one, so we don't have that sort of reference there. Keeping in mind that our limits are -2%. Sorry, wrong button. So there's my -2%. If this is my theoretically correct number, and it's not precisely accurate, so please don't get too picky with me here. It's just a line on the graph. There's my -2 number. And you'll notice that none of the tested software at this preliminary stage, there were 5 software they looked at, none of them were below the -2%. So that's a good thing. Nobody's going to buy an undersized furnace because of these softwares. But the flip side is 4 of the 5 were above the 20% threshold. So they were overestimating or over-calculating the heat loss by more than 20%, which now if you were to go and apply or buy the next sort of furnace up from that number, there's a very good chance you bought a furnace that was bigger than it needed to be. because the software is already 20% inaccurate, and if you're a conservative kind of person, you always like to buy 20% over the excuse me, the number that your software generated for you. We could now be quite a bit bigger than is necessary. So 4 of the 5 softwares at this preliminary stage were actually overcalculated, and one of them quite substantially. Similarly, on cooling load, here's my -2%, and oh, this is not so good. I've got 2 numbers that came out well below the 2% number. So -2%, you say, oh, that's not a big deal, John, but it's not good to have a number that's less than the theoretical load. But then the counterpart to that is none of them were actually exceeding by 20%. So I'm not going to buy oversized air conditioners based on this, on these softwares. So that's a good thing. But the fact that 1 or 2 of them are actually below our tighter tolerance of -2 at the bottom end is a bit alarming, to say the least. I wasn't involved in this phase. I can pretty much guarantee you, though, that this is HOT 2000, which is not a heat loss, heat gain design software per se. It's an energy simulation software, and it's notoriously bad on the cooling side for some known reasons and perhaps some unknown reasons. But that's just a guess on my part. So what was the scope? What do we do here? So we developed some, so the CSA standard was written, and then HVAC DC got a contract with Enercan to do what? Well, to develop procedures, to test up to 8 software, and to launch a website listing the software, and to develop a report, final report. This presentation is essentially that final report. It was presented back in February on an HVAC DC webinar, similar to this one, but hosted actually by HVAC DC. And of course, the government got their copy of the presentation, and lots of conversation. They've been the people who are sponsoring this at Enercan are very involved and very passionate about this. 7 software have been verified and listed. Back in February when I did this presentation, I think it was only 4 or 5. I've forgotten the exact number. This is a QR code to get you to the actual verified listing. Not all of them are commercially available, so they're going to show up, but you may not be able to go out and buy them, and that's fine. I'll talk a little bit more about that in a second. And there's the listing as it stands today. This is just a screenshot of the website. Basically, we're just saying, these are it, right? There's their website. There's some conditions. I'm going to talk about that in a second. About the only thing we're differentiating on them at this point is whether they do room by room, which of course the vast majority do, or only whole house. And there's only one software out there right now that's just whole house alone. It's called Volta Snap. It's actually an extension that they may not like that word, but it's an extension of HOT 2000, that energy simulation software I just told you about. And what they're doing is taking the geometry data and R value data out of HOT, and they're doing a bunch of stuff. This is just a very small scope of what they do, and then manipulating it into that F280. And they're overcoming the weaknesses that HOT has regarding heat loss calculations. Commercial softwares here, Avenir, HeatCAD, Heat Loop, Right Suite Universal, and Tekka software, Tekka Thermal Environment Comfort Association on the West Coast. Theirs is commercially available, and then the others currently are in-house software. Once the software is verified, they get to advertise that if they want. So we have a logo use agreement in place. We have a verified software logo. It's a bit of a derivation of the HVAC DC designers logo and our corporate logo. So once they get verified, they can use that. And again, the verification process, if you are a software developer or you've got an in-house software that you want verified, there is a web page to that as well. What did we learn doing this process? The procedures, which I was lucky, they were largely in place. I shouldn't say they're largely in place, but the sort of core all the tests, those 48 tests I told you about, those procedures are largely in place. I basically embellished them with a little bit of graphics and stuff like that. We found some gaps in them and some challenges with them. We found a few mistakes in our various spreadsheets we were using for this, but basically they were in place. And then I put the before and after stuff onto it. So how do you, as a developer, how do you get your software into the process? Then all the steps are largely written for me. And then how do we report and what do we say and what are the conditions we're applying to this stuff? Software functionality ranges widely. As I've already mentioned, there's some software has graphical interfaces to them. Some of them are basically spreadsheet based. There were some bugs that we found, which of course the developers were kind of grateful to know that we were looking at it this closely and I could steer them to where I thought the problem was. The reports, this is spun off the reports that the software generate. F280 has always had an input report that's required. And so whether you're doing a manual set of calculations or whether you're using the HRAI worksheets or whether you've got your own spreadsheet or whether you're using some of the more sophisticated commercially available softwares, F280 says, tell me what the inputs to your program were. Tell me about the type of structures you had. Tell me about what drawings you used. Oh, I've forgotten them all. They're in Appendix D and E of F280, and they're pretty explicit about what the inputs are. What we've realized and what we're working on as part of the municipal engagement part of the process is we don't have a consistent output report. Many people sort of take that input report and sort of make it a little bit like the outputs, but there is no prescribed format on how the room by room loads and the total loads and the ventilation loads and stuff like that. There's nothing that tells us how to format that or what the minimum amount of information that should be produced is. So HVAC DC has developed that. They're trying to engage municipalities to use it, to sort of put it out to the designers to say, hey, you got to fill this in or have a report that looks like this. And if I understand correctly, the goal is to actually get that into the next revision of F280 so it becomes truly mandatory. We're constantly reminded, certainly from that first pre-testing evaluation of the 5 software packages. When I took this project on to do the official testing, I was reminded by almost all of the software developers that when they got the files back from what we're calling our qualified operator, the person who's doing the data entry, they said, yeah, there were mistakes in the file. They missed a window. They got this number wrong. So there's no doubt that there's user errors that creep into any calculation, including this testing. And obviously, I learned a few lessons about where the typical errors were, so I was able to steer people, the qualified operators, the input people, I was able to steer them a little bit. But it's also one reason why there's value to how we've set up this process where we've got an independent operator who collaborates with the person driving the testing process, which was me in these cases, and with the developer, and we can dialogue and collaborate and make sure we get everything. We don't want, of course, the developers doing their own testing because there's no third-party separation. There's no arm's length thing here. But to have the developer review the files that we have generated as the testing people and say, hey, you screwed up there, that's part of the process. And that's just the way it is. We all make mistakes, and having the two parties, the developer who's self-interested and the independent tester, was great. And then I performed a role we call the testing agent, which is sort of facilitate all this discussion. But the real big thing is the developers were committed to this, man. They were on board. Some of them had to go through corporate hoops to sort of sign on and give permission to share the software and blah, blah, blah. But once they got engaged, they were truly committed. They want their software to do the right thing, not just to look good and have fancy bells and whistles, but to come out with the numbers. There were things that upset them, but they addressed them aggressively with us, problems with the procedures that were draft. They were a first go, and they had both the pleasure of getting through this process for free as well as helping us troubleshoot the procedures. We definitely identified software issues. Some of them were sort of critical and were fail-worthy, and they overcame them. Some of them I was giving them some advice about how they format the reports and decimal places, which were not agreeing and stuff like that. Stuff I knew is trivial, but sort of reduces the credibility of these people. See some stuff coming up in the chat. I'm actually monitoring the question and answer thing a little more closely. Question there, who are the typical users of this type of software? Well, the softwares we tested were of 2 flavors, as I mentioned, commercially available software and in-house software. Regardless, they're all being used by HVAC designers. And the question is, are they paying a developer for their software and therefore sort of expect a higher level of support, or is it just an HVAC designer or a mechanical contractor or whoever who's developed their own spreadsheet-based solution, and they don't have sort of overwhelming support and manuals and YouTube videos and stuff like that, but this because it's their spreadsheet, their software, so they're used to using it and they know all its tricks and foibles. But the bottom line is we're talking about HVAC designers. Oops, let me get the right thing here. Some software have conditions. This was something we didn't fully anticipate as the process started. So as I talked about the procedures being refined and developed, this is something that I became painfully aware of, is that not all software, to be blunt, is created equal. They can generate good answers, but they've got some hangups with them. The big one is that the what we call the CSA calculators, or the spreadsheets that come when you buy the CSA standard. There's 3 of them. There's 2 foundation calculators, basements and slab on grades, and there's the infiltration, the air leakage calculator. They are relatively complicated spreadsheets as delivered by CSA when you buy the standard. And in fact, all the supporting documentation for them is included when you buy the standard, and it's like people's PhD dissertations and stuff like that. It is remarkably sophisticated stuff. I have a fairly good grasp on the infiltration calculator because it's something that's sort of near and dear to me, but the foundation calculators are just, they're wild, man. And consequently, some software developers, specifically the guys who've developed their own spreadsheet, they said, no, why would I spend the time and effort to understand and recreate that when I've got the F280 calculator courtesy of buying the standard? So in that case, the condition is very simple. We just want you to include an output from the calculator with your report. So when you generate your final calculations and you spit out whatever your spreadsheet generates in terms of a heat loss calculation, then you just need to staple or append or PDF with it the F280 calculators. Nope, there's no problem. We're not complaining about this. We just say, hey, we should document this a bit more thoroughly. So that's a condition we assign to some of the softwares because we weren't testing their ability to generate a foundation heat loss. We were testing their ability to take the F280 heat loss, calculator heat loss, and put it into their software. And so, like I said, it's cool. Nothing wrong with that. We just thought it should be flagged explicitly in our what we're calling conditions. The second one on a very similar front was we did test in the software protocols, in the F280 protocols, we're testing exterior window shading. So does your software adequately calculate the impact of having an overhang over top of window? This is solely on heat gains. It's got nothing to do with heat loss. And so we said, hey, if you don't have that built into your software, and you're doing either a manual calculation or you've got a little separate spreadsheet for the shading calculations to differentiate the shaded and unshaded part of the window, once again, attach that report to your report. So attach that shading calculation to your report. And then the third one was is a little trickier. It's we've got some guidelines around how well is the software supported. Does it have a manual? I don't think anybody has manuals today. The paper manual for sure is a thing of the past. But does it have either context sensitive help? Does it have, if it's a spreadsheet, is there maybe a cell that has sort of instructions for what to do here? Do you use the comment function in Excel to give instructions? Do you use shading? And then we also stipulated if it is a spreadsheet based software solution, that all the cells shall be locked except for the input shells to prevent accidental modification. We don't even ask for it to be password protected. We just want that truly accidental modification to be avoided. So lock all the cells that aren't input cells, and that's part of this, broadly speaking, this qualified user thing. So if the software is not well supported, some of the software people, they've got fairly thin support within the software, but they've got YouTube training videos and stuff like that. So they've got lots of resources. So if your software doesn't have adequate resources, then you are only the people who are approved by the developer are allowed to use it. And so there's going to be a listing on the conditions page that says software XYZ can only be used by John Harris. He's the guy who developed, he knows how it works. Oh, and by the way, he trained Mary Manti to use it too, so she can use it. Those are the only 2 people who can use this software because it doesn't have that robust set of help or manuals or training videos or whatever it might be. And so each software, when you go to the website and you see that first page that I showed you before, in fact, let me flip back to it. I should have paused briefly there. Sorry, bear with me. It's been a while since I've looked at this. I don't appear to have it here. So back to that software, the listing, so if you click here, you'll find a conditions page. They're all sort of formatted identical. It includes the date it was verified. It's got the version number that was verified there. Note that there is no version number here. So on the conditions page, we go to the date, the version, and going forward, it's deemed a verified going forward. The website's repeated, and then there's these 3 conditions. Does it need the F280 calculators with it? Does it need the window shading? Does it need does it have a list of approved users? And I encourage you all to go to the website and check those out. So sorry for the backtracking. I should add a slide there. So that's the conditions. And again, that was something that came up halfway through the process as we got past the commercially available softwares, which were sort of the first ones that were launched, and the spreadsheet-based software sort of came along a little later as the developers had tuned them up and prettied them up for us. So where's the future going on this? The future is that we will maintain and update this resource going forward. So this listing of verified softwares is something that we're standing behind. We're going to get up there. The re-verification will sort of be done as required. This was actually, we had a forum with all the developers at the table, and we said, what does this look like? Because basically I was saying my initial off the bat thing was whenever you got a new version number, it's got to be retested. And they went, no, John, we sometimes it's just, it's an unrelated part of the software. So for example, some of the more sophisticated software has duct design built into it. Well, if they modify that, why on earth would we re-verify the F280 compliance? And I went, oh yeah, okay, I hadn't thought of that. Or sometimes they're just updating the report to give it a little more pizzazz or what have you. So basically, at this point, we're backing off to say whenever F280 changes, in other words, there is a substantive change to the actual formulas we use. Well, then clearly we have to re-verify the software at that point. And after that, we're going to sort of deal with it on a complaint basis. If somebody says, "Hey, we don't think this software is compliant," we'll talk to the developers and we'll look at it at that stage. Clearly, we're trying to get additional software in. We've had 2 inquiries since we sort of went live with this. At this point, none of them have come through, but literally the last one was just responded to yesterday, so that's asking a bit much. I just want to say to anybody on the show, on the webinar today, if you have an in-house application and if you want this, the credibility behind this, and by the way, HVAC DC's goal as they reach out to municipalities is to say, hey, you really should look at whether or not the software is verified. So authorities having jurisdiction, municipalities, plans examiners are their own beast. They're going to do what they're going to do. But we're trying to say, what do you know about that software? Do you know that it's actually F280 compliant? This isn't new, by the way. South of the border, ACA verifies software too. I don't know anything about their process, so don't ask me. But ACA verifies manual J software in their case, is the American equivalent to our F280. So if you want to find out more about verification, I'll throw out just off the bat, I mean, if you've got your own in-house spreadsheet, wonderful. I hope you've got a copy of F280. I hope you've got the newest version, which has all these testing protocols and that you've at least glanced at them so you understand what we deem to be the proper process as well as the proper numbers. In the F280 that approved software. So question there is it not in the F280 that approved software must be used? No, I'd have to reread it to make sure I'm not telling any lies here, but F280 is a calculation, is a design standard. And it doesn't preclude, among other things, Chris, it doesn't preclude me doing it by hand. So I feel pretty comfortable saying that F280 is silent on the mandatoriness of software. What they've done is put the process in place so that the people who reference the standard, I'm talking building codes here, whoever references a standard can say, and we want it verified to section, software must be verified to section 8 of F280 or something like that. Now, that's just the current status. Will F280 actually, well, again, I sit in my little basement office and I develop a spreadsheet. Who's sort of got my authority over me? Not F280, not CSA. CSA puts standards out there. So anyway, I'm waffling a little bit on that, Chris, but the short answer is no. F280, if I remember it correctly, doesn't say anything about software must be verified. It just gives us the process in which to do that. And I would be happy to be corrected if I've got that wrong. So on that note, and I've sort of said this already, a second part of this project, and I had those 3 bullets listed up before, has been to reach out to municipalities to help them in their HVAC review. Again, we're lucky for those of us who are Ontario-based, if you want to call it lucky, to have a reasonably robust set of municipalities who do this already, who do it well, who maybe don't do it well in some cases. But having said that, we did get, as we did our outreach, we did find, I think it was just one, Mary can correct me, one Ontario municipality, no, I think 2 now that I think about it, did come along for the ride in this engagement with us. And these are smaller municipalities, and they just said, yeah, we could use some help with what constitutes a good HVAC review. And I'm actually separated from that project. I don't know much about it. So if you want to learn more about it, we could put a request into Mary to facilitate putting that kind of webinar together. And then the third thing, and this is coming from a second bucket of funding, and it's therefore start up a little bit later, is to get an accredited designer listing. And this is going to be launching soon, if I've got the story straight, Mary. And it basically, we're looking for qualifications for HVAC designers from the various people out there, HRAI being the primary one, TECA in BC be a very strong group in the west side of the country. Show us a list of accreditations and show us that you've got insurance, and there's a couple other things I've forgotten what they are, and we'll list you as an accredited designer. The end game being, if a municipal plans examiner looks at a set of heat loss designs and sees that the software is verified and that the designer is accredited, they will actually just close the file right there and put an approved stamp on it. That's the goal. That's what we'd like to see. A verified software, accredited designer, move that file along. I don't need to look at it. That's what we'd like to see. So I preempted that, and maybe I'm repeating something we're going to see here. So the end game is proper load calcs, diligent equipment sizing, which again is separate from this project that I'm talking to you about today, but is the natural carry on after we get the load calcs. We do good equipment sizing. Will give us a lower cost installation. Will give us potentially smaller ductwork. Will give us maximum efficiency on heat pumps. Heat pumps are sensitive to sizing, right? If they short cycle, this is becoming less of an issue with inverters and variable capacities and stuff like that, but it's still a truism. Maximum efficiency for the heat pump, improved comfort, again, less important with variable capacity machines, but not untrue, and the greatest greenhouse gas reductions. So this is, and reminding us that we've discovered this impact on the electrical grid that is very important to some utilities. So this is another spin-off thing that we hadn't anticipated when we started the project. So that's it. That's my last official slide. There's Mary's email address at HVAC DC, by the way. So if you have questions, follow-up questions, or if you want to find out more about the verification process or what have you, there's Mary's contact information. I don't mind. I'll put my email in the chat as well if anybody's got questions for me directly. But really, go to Mary is the right channel. Did I get that right? Yeah. So there you go. Any additional questions?
Yeah, we definitely have some time for questions. I think Mary is still there as well, so her contact is on the page. John just put his email into the chat as well. But if you're watching this on the video, it is jharris, JHARRIS, at dsgi.on.ca. jharris at dsgi.on.ca. So you can reach out to either one of them, or you can, yeah, I guess that's the options. Thank you so much, John. A lot of great information. We will have this video up on the HRAI YouTube page shortly if people need to review. But any parting words while people kind of put together any questions, or we get ready to go?
Yeah.
Yeah.
I don't have anything to add.
Okay, great. Mary, oh, thank you from BC, says Ed Bradbury. So we got some across Canada listeners.
Excellent.
Awesome. Okay, I think we'll conclude. Oh, thanks all. Great to get the update, and see you in front of class again, says Chris Walsh.
Thanks, Chris.
I assume you know Chris. Great. Good attendance today. I really appreciate it. We have, oh, I think while I'm killing time, there you go. Oh, yeah, we have two questions. I don't know if you can see in your Q&A button there. Yeah,
I got them. So Dale, will we discuss the slab and basement methodology of F280? The answer is no, I'm not smart enough. As I said before, the F280 calculators are based on a whole whack of research coming out of Concordia University, if memory serves. I could be wrong there. And it's, I know a little bit of the background because I've been working with HOT 2000. This stuff came out of the energy simulation software from Enercan, HOT 2000, and it basically got modified into a spreadsheet and published with the F280 standard. So, I mean, it needs good geometry. It needs a length and width. It's very rectangular oriented. So you have to generate an equivalent length and width for a non-rectangular slab or basement. It needs proper R value assessments. It needs to know the climate zone that you're in. Technically, it needs to know things like soil conductivity and water table level, which is very hard for an HVAC designer to get. So if memory serves, if you go to all the help stuff that came with the F280 standard, it does point us towards an acceptable default for those kind of factors. I'm just going by memory here. Needs depth below grade for a basement or height above grade. And they're just relatively sophisticated. Having said that, when you buy F280, you get all that background information. You get a bunch of spreadsheets that allow you to test your implementation of it. And so if you are a developer and you want to get it up and running and incorporate it into your software, like I say, it's a bit beyond what I would be able to do comfortably. I've been able to do the infiltration one. I got the air leakage one running in a spreadsheet of my own, but it's something I'm more familiar with. I don't know if that answers your question fully, Dale, but that's that. Cynthia, you're asking a question I refuse to answer. Did you find any weakness in RightSoft? The answer is I think we found something, but they fixed it. So no, there's no weaknesses in RightSoft. RightSoft is a sophisticated software. It's got a huge following, so we actually had a very qualified person using it. Having said that, there were geometry issues to address with the walkout basement that we had to tweak to get the final answers to come through. If anybody is anticipating getting their software verified, I will tell you right up front that the walkout basement, archetype number 2, we call it, is tricky to just get your head wrapped around. Spend some time looking at the plans and looking at the geometry tables that are in F280 to get your head wrapped around that.
Fantastic. There's no further questions. I think we'll call it there. And yeah, thank you so much again, John, Mary, and we hope to see you back sometime.
Excellent. Thank you.
Thanks, everyone.
Have a great afternoon, all.